Hello there. This video will be the first part of a three-part series on solving and sketching quadratics. In this first section, we'll be looking at solving quadratics using factorization. I put method 1 here because we are going to be learning about other methods to solve quadratics. But if you're doing foundation, this is the only method you need to know. So let's do a quick recap of quadratics. But before I do that, I just want to let you know that I did a video on factorization. If you know how to factorize quadratic expressions such as this, you'll be fine. But if you want a recap or if you just don't know how, I'll have a link to that video in the description, and I strongly suggest you have a look at that before watching this video. Okay. Anyways, to recap quadratics have the form, do this in red, ax squared plus bx plus c. That's the form they're in. But what are a, b, and c? What do they represent? Well, a, b, and c are constants. So that means they don't change. But it also means that they're not dictated by some kind of variable. They're just numbers, if you will. So now we have this quadratic form, and you can see that here this isn't a quadratic form if you just ignore the equals 0, and this is what we learnt about in the factorization video. That in this case, a is equal to 1, b is equal to -7, and c is equal to 6, because they denote these constants in this form. Another thing is quadratics are a curve like this or like this, for example, on the graph. These are two examples of quadratics and how they look on the graph. We will be looking at sketching quadratics later on, so it doesn't matter if this is confusing you. Okay, but anyways, we are going to use factorization to now solve quadratics. So in the factorization video, if you remember, we learnt how to put this form, so using factorization, we put in a form like this, x minus a, x minus b, for example. And this is in its factorized form. Or it can be x plus a and x plus b, but you don't really need to worry about this notation. But we learned how to factorize these, we learned how to factorize these quadratics. Now what we're going to do is we're going to solve them. And we can only solve them when there's an equals sign here, because you can't solve something that's not an equation, or something that doesn't have an equals sign. So because we do, we can actually solve it. And solving just means find x. Find out what x is. So let's use this first method, factorization, to solve this. So what we're going to do is, first of all, we're just going to factorize the left-hand side of the equation. So remember, to factorize, we need to find two numbers that multiply to give c, which in this case is 6, and two numbers that add together to give -7, which is b. If you want, you can pause the video before I say what it is. So 6 and 1 multiply together to give 6. -6 and -1 also multiply together to give 6. And minus 6 plus minus 1 give minus 7. So just because you have a positive number here, it doesn't mean that the terms in these two placeholders can't be negative. Because remember, when two negatives multiply together, they give a positive. Now, if this wasn't a negative, we'd probably be looking at positives. But because we have a minus 7, we know we need to add negative numbers, or at least one negative number. Now that we know these, we can write it in our factorized form, like so. Okay, so now I'm just going to move this up here. And then from here, it's been pretty similar to what we were learning in the factorization video. So we've factorized it, and now we have this equal 0 here. Now let's think about it a little bit and see, when can this term here, or the left hand side, when can that equal 0? Because we want it to equal 0. Now for example, if x minus 6 equals 0, in fact, I'll write this in a different color. If x minus 6 equals 0, so if x minus 6 equals 0, then we have this equal to 0, so we'll have 0 times by x minus 1. Well, that equals 0. And if x minus 1 equals 0, then we'll have x minus 6 times 0, which also equals 0. So both of these fit the equation. It's a pretty bright green. Both of these fit this top equation here. Because it equals 0. So now what we can say is, okay, so what does x have to be in these conditions? Well, if we look at the top one, we get x minus 6 equals 0. That's the same thing as if we add 6 to both sides, we get x equals 6. And then this bottom one, x minus 1 equals 0, we can add 1 to both sides to get x equals 1. So these are our answers. X equals 6 or x equals 1. So you can see that we've actually gotten two answers here, and I can show you this with a check. So we're going to substitute them back into this initial formula to figure out if they're correct. So let's substitute in 6. In fact, let's not put that in yet. We know this equals, well, that's 36 minus 42 plus 6, like so. And you can see that 36 minus 42 is minus 6, and then we have add 6, which is 0. Okay, now let's check 1. So I'm just substituting both of these values into this initial equation. So we get 1 minus 7 plus 6, which is, again, minus 6 plus 6, which is 0. So, both of these give an answer to this, and that's a property of quadratics. They have two solutions. They can have two solutions. So, if you're getting one solution, you might recheck and make sure that you've got the correct solution, or that you've not missed the solution. And just to recap here, we're just we want this to equal 0. In other words, once we factorize it, we want this to equal 0. And for this to equal 0, either this term equals 0 or this term equals 0. And then we just have to figure out what x has to be for this to equal 0. For example, if x is 6, then we get 6 minus 6 here, and that'll make the whole thing 0. And if we have 1, 1 minus 1 equals 0. Okay, let's do a few more examples. Now, you'll get quadratics like this quite often, where this coefficient here is not 1. Now, if you're doing higher, you'll probably know how to factorize it when this number here, the a bit, isn't 1. But it's still a lot more difficult than factorizing it if it was just 1. Obviously, it would be easier if we could somehow make this quadratic into just 1x squared and factorize that rather than keeping it at 2x squared. And there's actually a way to do that. And it's by dividing this quadratic. So if all of the terms in the quadratic are divisible by a certain number, we can divide through by them. So because each of them can divide by 2, we can just divide the whole equation by 2. So 2x squared goes to x squared. Minus 14x goes to minus 7x. 24 goes to 12. And because 0 divided by 2 is just 0, that stays the same. Remember though, you have to divide every single term by 2. And you can only do this when you have an equation, so when it equals 0. Okay, so now that we've got it in this form, it's a lot easier. We can just do the same thing. So let's find two numbers that multiply to give 12, add to give minus 7. There we go. Okay, and again, we have a positive here, so it's either two positive numbers or two negative numbers. Because we have a minus here, it's going to be two negative numbers. And it turns out to be minus 3 and minus 4. So let's put those in our brackets. Let's not forget the 0. And we know that x minus 3 equals 0. For it to be equal to 0, because then this will go to 0. So we get x equals 3. And x minus 4 equals 0, so x equals 4. These are our two answers. Right, now for this one, again, we haven't got a 1 here. We've got a minus 1. But thankfully, we can use a similar process. We can divide, or in this case, we can even just multiply by minus 1. Now, if we multiply everything by minus 1, when you multiply by minus 1, you just swap the signs of the term. So minus x squared becomes 1x squared, which is great because that's what we want. And then minus 3x becomes plus 3x, plus 4 becomes minus 4. And again, 0 and minus 0 are the same. So we just get 0. So now we can, again, solve a much easier quadratic. So here we want to multiply to give minus 4, add to give 3. Now what we can see is that the first this value is negative, so we need a positive and a negative to get a negative. And it ends up being 1 and minus 4. My bad. Minus 1 and 4. Okay, I'm mixed up. Because minus 1 and 4 make minus 4. And minus 1 plus 4 gives us 3. So again, let's put those into our brackets. Again, not forgetting the plus 0 there, or equals 0 there. And then after that we get x minus 1 equals 0, or x plus 4 equals 0. In other words, x equals 1 or x equals minus 4. So those are our two answers. From here on out, this video is all on higher content. So if you're doing foundation, you don't have to look at the rest of this video, but there are exercises at the end if you're interested. If you're doing higher, listen up, because now we're going to try and solve this. Well, now we can see that, yeah, we could divide this by 5 if we're using the same process as last time, or the last two examples. But when we do that, we end up getting 11 over 5x plus 2 over 5 equals 0. And now it's a lot harder to find two numbers that multiply to give 2 over 5 and add to give 11 over 5. So in this case, if all of the terms aren't divisible by 5, the best thing to do is to just use the more complicated factorization method. So let's do that. So step 1, let's start with that. So step 1, if you remember, is to find two numbers that multiply together to give a times c. So in this case, it's 5 times 2, so 10, which also add together to give minus 11. Now, we have a negative here and a positive here. We've learned that that probably means that we have to multiply two negatives together. Well, which two negatives? Well, this is 1 more than 10, the positive version. So it's probably going to be 10, minus 10, and minus 1. Like that. Now, on to step 2. We split this top quadratic. So we split into these two. So we get minus 10x minus x plus 2. So all we've done is we've split this middle term up into these two parts because it adds together to give that middle term. Let's split that. And now for step 3, we take out common factors on both sides. So let's do that. So on this side, we can take out 5 because both of them go into 5 and nothing larger. And we also have an x that we can take out on both sides. So we need to divide this by 5x. 5 divided by 5 is just 1. X squared divided by x is just x. And similarly here, the x's cancel and we get 10 divided by 5, which is minus 2. And then here, we want x minus 2 in the bracket. So if you remember, we can divide by minus 1 and swap these signs. So the minus x turns to x, and the 2 turns to minus 2. And now we have the same bracket. And then as for step 4, we get the terms outside the bracket, so 5x minus 1. And then we get the terms inside the brackets, but we only use one of them, like so. And there we go. We factorized it using the more difficult method. If you want, you can put plus equals zeros here. It would be sufficient just to put one here, but it helps you remember if you do it all the way through. Now, let's do this again, the same process. So we say it can either equal 0 when 5x minus 1 equals 0, or when x minus 2 equals 0. So when 5x minus 1 equals 0, you can move the 1 over. So we get 5x equals 1. Here we can get we can move the 2 over, so we get x equals 2. But in this case, there's an extra step because we have this x here that we want by itself, but we have 5x. So we need to also divide by 5. So we get x on the left and then 1 over 5 on the right. So our answer is a fifth and 2. Okay. Now we're going to move on to our second method. So again, this is all still higher content. So only on the higher specification. So we're going to solve quadratics using the quadratic formula. So this is method 2. So this is the quadratic formula. So if ax squared plus bx plus c equals 0, so this is the form we're already familiar with, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, that is a mouthful, but it's a really, really nice way of just finding x, especially when the equations are pretty complicated and you don't want to use the long-winded method of factorizing, and if you have a calculator. Now, you can also see this equation in the lowercase form. So you can also see it like this, but all the letters are lowercase. But it doesn't matter. It still means the same thing. It's just in the form they'll be like that. It's going off the screen. I'll move it. So like that. Okay. So how do we actually use this? So here I've brought this exact same quadratic that we used in the last example, but instead of using this long-winded method, we're going to use the quadratic formula. So let's figure out what our a, b, and c are. So we can actually label them here, but let's just write it out clearly. So a equals 5. Remember, b equals minus 11. And c equals 2. And now we can substitute these into this formula to find x. Right. So negative b is minus... In fact, instead of evaluating anything right now, let's just put everything in raw. So we're just going to literally just use brackets for everything. So we know b is minus 11, so let's just put that in there. This plus and minus thing, I'll touch on that later. So now again we have b squared, so that's minus 11 squared. Minus 4. A is 5, so we put that. And then c is 2. And then over 2 times 5. Like so. Now, I know it's tempting, for example, at the bottom, to write in 10. Instead of 2 times 5, but for now you're gonna make you're gonna have a tendency to make mistakes if you just jump straight in and start doing calculations. It's always easier to just put in all the values and then start evaluating. So to begin with, these two negatives cancel out, so we just get 11 plus or minus. Now here we have 11 squared, so that is 121. And 5 times 2 is 10, times 4 is 40. So we get minus 40. And then at the bottom we get 10. So now let's finish off this square root here. So we get 81 over 10. And the square root of 81 is just 9. Right. So now I'll tell you what this fraction means. What this plus or minus in this fraction means. Basically, plus or minus means that to get our two values of x, because remember, quadratics give us two answers. This is only one answer. But what this symbol means is that you can split up the two conditions. So we have 11 plus 9 over 10 as an answer, or we have x being 11 minus 9 over 10. So at the very end, once you've simplified it down as much as you can, then split the two conditions, the plus and the minus, and then evaluate them both separately. So in this case, 11 plus 9 is 20, over 10 is just 2. And then we have 11 minus 9, which is 2 over 10. That simplifies down to a fifth. If any of that seemed fast, just do the calculation in the numerator and you will get the same answer. Okay, great. Now, just a bit of theory for this. Just a bit of theory for why we say it's plus or minus. So when we square root, in fact, when we square 9, we get 81. But when we square minus 9, when we multiply minus 9 by minus 9, the negatives cancel out. So again, we get 81. So it doesn't matter whether it's plus 9 or negative 9. We'll still get 81. So when we're square rooting 81, we can either get 9 or minus 9. Because we don't know what it could have been, what we squared to get 81 in the first place. So when we're square rooting, it could either be 2 9s multiplying together or 2 minus 9s multiplying together. That's why the plus or minus works. That's why we get 2 answers. So let's have a look at this equation. So it actually doesn't really look like the form we're used to. Like, what is A, what's B, what's C, and why isn't there a 0? Well, sometimes you'll get questions like this, and what you need to try and do is rearrange it so you only have 0 on the other side. So basically we want to put all of the terms onto one side of the equation. Now you can either move the 1 over here, but it's better if we make sure that this is a positive, this x squared term. It'll make our life easier. So what we can do instead is we can move this to the right, to the left, sorry, and move this to the left. So let's do that. Whoops. So we move this over, giving us positive x squared. We also move this over, giving us minus 4x, and the 1 stays the same. And now we have our 0 because we moved everything to the left. So now we have our equals 0. And only when we have our equals 0 and this in this form here, only then can we start to solve it. So again, we have a A, we have a B, we have a C. Or in other words, we can write A equals 1, B equals minus 4, C equals 1. Okay, so let's do that. So we get x equals, what we're going to do is we're just going to write out the equation. This is always good to write out because it means that you'll remember it. So if you don't know it, even if you have to look, the more you write it, the quicker you'll get it into your head. So, and then after we do that, then we substitute all the numbers in, but we don't evaluate anything. We just put them in. Like so. Like that. Again, it would be really easy to just say that's just minus 4, but taking it slow will make sure we don't make mistakes. So again, the negatives cancel out here. We have plus or minus. 4 squared is 16, and we have minus 4 because the 1s go away when we're multiplying. And then at the bottom, again, we'll just have 2. That equals 4 plus or minus root 12 over 2. And now we have a slight issue because we can't evaluate root 12 as easily as we could with root 81 because this doesn't give us a whole number. But if you think back to simplifying surds, we can actually simplify this surd. So I'm going to do this on the side. So root 12 to simplify root 12, we need to find the largest square factor. So it would help to actually just list all the square factors up to 12. So the next one's 16, but we don't need that because 16 is higher than 12, so it can't be a factor of 12. So now we can see that 9 doesn't go into 12. 1 does, but 4 also does, and that's higher. So what we can do is we can write this as 4 times by, well, we just do 12 divided by 4 to get 3. And then because of the rules of surds, we can split this up like so. And then now we can evaluate that root 4 to just give 2 root 3, like so. So we know that root 12 equals 2 root 3. So if we go back to our question, we can substitute 2 root 3 over 2, like so. And now what we can do is we can divide all the terms by 2. So what we're going to do is, or in fact, we can just split the fraction first, if that makes it easier. Remember, we can split this, even though it's a plus or minus, we can still split it. So now 4 divided by 2 is 2, and 2 root 3 divided by 2, well, the 2's cancel out, so we just get root 3, plus or minus root 3. And now we can write our two different values, so we get 2 plus root 3, or x equals 2 minus root 3. Because we can't simplify the root 3 any further, we have to leave it like that. Just a side note that you cannot use factorization for this because you have a surd, and it would give you really awful numbers to try to find. So these two numbers here would be really awful, so it would be very difficult to find the answer. But yeah. So let's this remark here. Yeah, method 3 is gonna be in a later video. So if we look back, we have method 1 for solving quadratics, which is factorization, and now we've learned this second method, which is a quadratic formula. And this method is better when you have a calculator or when the numbers are quite complex. There is a third method that's also used called completing the square, but we will do that in the third video in this series. Okay, but I just want to touch on some problem solving questions that could be asked. So these use quadratics to make up more problem solving style questions. So this links in another topic. So here it says the area of this triangle is 14 centimeters squared. Find x. So we can use the area of a triangle to solve this. And if you want to do this by yourself, you have the tools available to you to do that. So you can pause it and try it if you want. So the area of a right-angled triangle in fact, it's more general than that. So the area of the triangle equals a half times the base times the height. But we're just going to write base times height, like so. So now what we can do is we can substitute values in for each of these. So the area is 14, tells us in the question, and that's a half times by the base, which is x plus 1, times by the height, which is 4x minus 2, like so. And now we can expand this left-hand side. In fact, I'm going to swap it around. So I'm just going to put them on the different sides of the equal sign. It doesn't really matter. And then let's expand this. So we get 4x times by x, which is 4x squared, and then minus 2 times x, which is minus 2x. Now we have 4x times by 1, which is just 4x, and minus 2 times 1, which is 2, minus 2, sorry. And that equals 14. Okay, we can actually simplify this middle bit to give us 2x. And now we can half everything. So our 4x squared becomes 2x squared. Our plus 2x becomes plus x. And our minus 2 becomes minus 1. Equals 14. Now, we can't actually solve. Remember, solving finds x, so we want to solve this. But it's not in the right form, because remember, we need it equals 0 on the right. So what we can do is we can just subtract 14 from both sides. So we'll get minus 15 here, and we'll get 0 here. And now we can just use any of the methods that we've learned so far to find this. But the method that I would use is the quadratic formula. So let's do that. So we have negative b, which is 1. You can also write out a, b, and c, but once you do more questions like this, you might just be able to read it from the expression. So we have minus 1, and then we have 1 squared minus 4 times 2, which is a, times minus 15, which is c, over 2 times a, which is 2. Like that. Now let's start evaluating. Sorry, I should have put an x there. So we get minus 1 plus or minus 1 here. You have minus 15 times 2, which is minus 30. These minuses actually cancel out. We can cancel those out. So we get a positive number. And then 15 times 2 is 30, times 4 is 120. And then 2 times 2 is 4. This is 121. And if you remember, we know that that's 11. Root 121 is 11. So now we have that. Okay, so now what we can do is we can split up the plus or the minus, the plus and the minus. So we get x equals 1 minus 1 plus 11 over 4. Or x equals minus 1 minus 11 over 4. This equals 10 over 4. Which is just 5 over 2. You can simplify it. You can also write it in decimal form. But it depends what the question wants. But fractions are always nicer. This at the top is minus 12 over 4. So that will give us minus 3. So those are our two answers. Okay, great. So now that you know how to use these two methods and problem solve with them, I'll give you these exercises. So for foundation, you only need to do the top one, but if you want, if you're doing higher, you should be able to do all of them. Just something for this bottom one, for this last example, or this last exercise. I have a hint here. If you don't want to use the hint, you can just pause the video now and do it, or else I'll reveal the hint in about 5 seconds to help. Okay, I'm going to remove the hint now. Yeah, you'll need to know Pythagoras' theorem. So if you've not learnt about that, maybe you can come back to this question when you've done that topic. But if you do know about it, you can use it. You'll need to use that to figure this one out.